I'll just go into, I'm going to talk about this relating to that.
Okay.
Because problem 2 is related. See, here's the problem with the problems is when I test you guys on the applications, the written part is basically application driven, and we spent a lot of the lecture time discussing the derivations and the proofs. And we didn't get a lot of time spent on the applications. So really the key is for the test, you practice the applications. The reason we want to focus the lecture attention on to the underlying physical principles, because everything we've done thus far was proved based on the 4 laws of thermodynamics and 2 physical laws, the gas law, the ideal gas law, and Boyle's law. And that was all we used, because the physical laws are irrefutable. They are unimpeachable. And so if we can state anything in terms of physical laws, you've made a statement that knows no exception. And you're on solid ground. And so the reason we have to understand that is to answer those well-loved multiple choice true-false questions that are going to occur at the end of the test. That tests your comprehension, so we can make the connection between this. So right now we're working on the written part, which is mostly applications. And the reason that we can justify this is there's about 300 billion, give or take a few, different equations that you need to know. And so you could set out to memorize all 300 billion equations and know which one applies to a given set of circumstances. Or you can learn 5 or 6 laws and know how to apply those to a given situation to derive the right ones. So that was the reason we had to learn it based on the law. So you can know 5 or 6 laws, and you can keep that in your head. It's just like you can know the logs of the first 5 prime numbers. That you can carry around. And then you just have to know how to manipulate that using the rules with exponents. And so the best approach for mortal human beings is to learn a few laws and learn how to apply them, rather than the Harry Potter approach where you just memorize a bunch of 300 billion equations and you could say Wingardium Leviosa and it'll go on nicely. So problem number 2 is 1 liter of an ideal gas in a cylinder under a frictionless piston with 9 atmospheres of weights placed on it. The external pressure is 1 atmosphere. How much work is done if the gas is expanded isothermally under the following conditions? So when I said isothermal, I referred to the Boyle's law condition. So we're using that empirical gas law. And that's the only one we're going to need for this particular application. And we've already shown that the work is equal to the W is equal to, so W is equal to minus P external times the change in volume. And the reason for the minus sign is because we use the convention that the work is being done by the system. And so the gas that's expanding, the force is equal and opposite to the external force of the gas that opposes it. So it's equal and opposite to. And we're assuming a frictionless system, so this is an ideal system. Okay, now in a 2-stage expansion, so part A is 2 stages, and it was 5 atmospheres removed first, and then 4 atmospheres. Exactly. 2-stage expansion, and for all time, for all stages, Boyle's law applies. This is an isothermal expansion. And so for all stages, PV is equal to a constant. And that's equal to, what was our initial conditions? We had 1 liter and 10 atmospheres. So it's 10 atmospheres times 1 liter equals 10 liter atmospheres. So that's going to be true the whole time. Product of the pressure and the volume is always going to be equal to 10 liter atmospheres. And now for the first stage, we've removed 5 atmospheres. So the external pressure is going to be how much? How much? 5 atmospheres. So P external is equal to 5 atmospheres. And V for the first stage is going to be equal to 10 liter atmospheres over 5 atmospheres equals 2 liters. And delta V1 for the first stage is going to be equal to 2 liters minus 1 liter equals 1 liter. Okay? And therefore, W for the first stage is equal to minus, it is, what was our final, our pressure is 5 atmospheres times 1 liter equals 5 liter atmospheres. Okay? And now, for stage 2, I just got a shadow. What?
-5 liters.
Oh, yeah. Thank you. Thank you very much. Okay. Now, for stage 2, we have, what's the external pressure now? 1 atmosphere. P external equals 1 atmosphere. And therefore, V2 is going to be equal to 10 liter atmospheres divided by 1 atmosphere equals 10 liters. And delta V2 is equal to 10 liters minus 2 liters equals 8 liters. Okay? And W2 is equal to minus 1 atmosphere times 8 liters equals minus 8 liter atmospheres. And the W total work done is equal to W1 plus W2 equals minus 5 liter atmospheres minus 8 liter atmospheres equals minus 13 liter atmospheres, which solves problem 2A. Is that pretty straight up?
Yep.
No questions about that? Okay, let's go on to part B.